There we go. Everything should be running now. Welcome to Comp 620 or Comp 422, Information Privacy and Security. Second day. Couple of announcements. Textbook should be available online for everyone. I believe if you go to Blackboard onto the class page, on the blue menu on the left side, scroll down to the bottom of the blue menu and you should see a tab that says textbooks. If you click on that, I think textbook should be available. Anybody find it? I sent an announcement. It's all working. I apologize that it wasn't there earlier. Looking back in the emails I got from Blackboard Helper, and they sent me a long email with multiple different topics, and near the bottom was something about, oh yes, make sure you click this. Well, I didn't see it. All right, skip past it. Anyway, I have clicked it and now it's available. So sorry, you got it there. Get the textbook. The introductory survey is due tomorrow at noon. About 83% of the students have already done it. Please make sure that the other 17% complete it, because the word mandatory is there and it counts towards the assignments. It will count 100 points. So if you don't do it, you get 0 points, and you want to, this is a very easy quiz. Nobody's complaining that it's too difficult. So you want to get those points whenever you can. Also note, tomorrow night is the last time to add a class or change sections or something. So if you decide you just can't stand Comp 620, you can jump ship and go register for something else. But tomorrow is the last day to do that. After tomorrow evening, you're stuck with it. You can drop classes until sometime in October, but you can't add in new classes. Some people asked me who's doing cybersecurity research. So I got some lists. Here are all the research centers. You can see that Dr. Roy is pretty busy. He's in the Center of Trustworthy AI, Center for Cyber Defense, Cyber Identity Lab, and the Cyber Defense and AI Lab, and other people participate. You can see those labs. And then these are the people working it. By the way, this and all the rest of the notes are available on Blackboard. I try to get the Blackboard notes out there before class, so you should be able to see all this. Then you wonder why even bother showing up. Okay, today we're going to talk about the definitions of cybersecurity. Got a couple of them. Talk about access control, in particular access control matrices and access control lists, and look how they're implemented. All right. A reminder for the online people. When I am sharing my screen, am I sharing my screen now? It says I'm sharing my screen. Okay. Hopefully you can see this. You can all see the slides. I cannot see the chat when I do this. So if you send a chat.
Yeah, we can see them.
Good deal. Thank you. You have to speak up. If you have a question or issue, yeah, I can't see the chat usually. So just yell at me. So if you have a question or anything about the class, just scream and I'll try to hear it. Okay. Okay, security. What is secure? Basically, system is secure if it does what you want it to do and doesn't do what you don't want it to do. That's a pretty vague but accurate assessment. It also works, by the way, for correctness. Program is correct if it does what you want it to do and doesn't do what you don't want it to do. We'll find during this class that correctness and secure are often closely related, that many insecure issues come from program problems, program errors. And so if you wrote the program correctly, then it wouldn't have those problems. It is a little bit vague, so we're going to try to be more formal. So we'll use some formalisms as described in the textbook. All right. So let's define a couple of states. We've got state P, which is all the possible states that a program can be in. And state Q is all the states that are secure. Now, we talk about states. We're not talking about California and North Carolina. We're talking about computer states. If you think of all the program variables in binary, all concatenated together, they make up one great big binary integer. It's a number. And so there is a series of numbers that the program can have. There's a whole bunch of numbers the program will never get to. You know, if you have 4i goes from 1 to 10, then I will never be negative. I will never be more than 10. So those are numbers that won't get there. And of all these possible states the program can get into, which we call P, the ones that are secure we'll call Q. So, got the notation? If the set of all states you can get into is a subset of all the states that are secure, then you've got a secure system. It can't get into any states that are unsecure. So that's good. If the set of program states you can get into is exactly the same as all the states that are secure, then that we call it precise, according to the textbook, and that's secure. Program will always be in a secure state. Unfortunately, sometimes you'll have program states that are outside of the secure states. In this diagram, you'll see Q. There are some states in P that are not in Q. The blue states are states that the program could get into, but are not secure. And so that would be an insecure execution. So those are insecure program. They call it broad. I would use the word insecure if there exist program states they can get into that are not secure. So a secure system always starts in an authorized or secure state and can never enter an unsecure state. During the execution of the program, it will never execute something that causes it to do something that's insecure. So it moves from state to state and never wanders into a state that's not in Q. You've got a breach of security when the system can run into a state that is not authorized. In this case, P is all the program states. If you get into one of the blue fields again, it's not part of Q, then you've got something insecure and is no longer secure. Now, it would be nice if we could write a program that would analyze another program, and say, well, it will always be in a secure state. That we could look at the program code or look at the executable, and our algorithm would go through it and say, oh, it will stay in a secure state. And therefore, we know that it's secure. Or we could detect that it's not secure. The problem is you can't do this, that this is an undecidable problem. Now, undecidable does not mean it's just hard. It means you can't get there from here. It means you cannot write an algorithm that you can get there. There are multiple undecidable problems in the computing world. The best known one is the halting problem, which hopefully people have heard of that without asking the folks online here in class. How many of you have heard of the halting problem? Okay, well, we'll talk a little bit about that then. Yes, there are multiple non-computable problems. The halting problem is a famous one. You can read about it on Google or Wikipedia, whatever you want to. But there are several others. Some of them are interesting. I have an example. Just for the record, no, this won't be on the exam, but it is kind of important as a computer person to know, so let me go over it. Besides, I had some grad students working a long time on this stuff because we were trying to find encryption algorithms based on non-computable problems. I thought that would be secure. It probably would be if we ever figured out, which we didn't. Okay, let's talk about the post-correspondence problem, which is a well-known non-computable problem. Like most of them, it's a decision problem. The answer is a yes or no. Can you do this? So imagine we have a set of tiles, like dominoes, and there's a number on the top and a number on the bottom. And just to make life simple, we'll make the numbers binary and not very long. We'll say, in this case, the example I'm using, the numbers are binary, and the numbers go from 1 to 3 digits. So it's a really simple problem. You can make it with longer numbers and more involved numbers. But the question is, can you take these tiles, assuming you have a whole bunch of each tile, a whole bunch of the orange ones, a whole bunch of the greens, a whole bunch of the blues, and can you line them up together such that the string of numbers on the top is identical to the string of numbers on the bottom? So you look at the example here, and you'll see that it has to start with the orange tile because the orange tile has a 1 on the top and a 1 on the bottom, and the green doesn't, and the blue doesn't. So it has to start with the orange. And after the orange, we got to have something that starts with the 0 on the bottom because it goes 1, 0, 0. So it's going to have a blue after it. And you can keep on going. And it turns out, here's the solution. Take 7 dominoes. If you look at the top, it goes 1, 0, 0, 1, 1, 0, and down to the bottom, it's 1, 0, 0, 1, 1. And they match. Kind of cool. Okay. Whoop. Stop that. So much for touchscreen systems. Okay. They match. Oh, wrong place. So there you are. Sorry, there is an example. And we can figure it out. So when you think, why is it uncomputable? We got an answer. In many uncomputable, undecidable problems, there are many instances that you can determine. It's just that you can't determine every instance. Here's a very similar. If you look at this one, the only difference between this problem and this one is that in this one, there's only 1 0 in the blue tile, whereas previously we had 2 zeros in the blue tile. So what? Well, it turns out this one has a solution, but it takes 75 tiles to do it. And so you have to keep trying until you get it. It's a much more evolved one. There are other problems with simple tiles that nobody knows if there is or isn't a solution. It's one of the difficulties in most non-computable problems is that it's not possible to enumerate all the possible solutions. And a lot of problems, if you have your NP-complete problems, well, you can always solve it by brute force because you can list all the possible answers and test them all. It may take a long time, but it's finite. With many of the undecidable problems, you can't even enumerate all the possible combinations, all the possible solutions, and then test them. So the previous problem took 75 tiles. If you tried solutions with 74 or less, you wouldn't have found it. How do you know when you get to the end? And so that's undecidable. There's also other ways to prove that it's undecidable. Another undecidable problem is Wang tiles. This is the one that I spent more time than I should have. So did a couple graduate students who wrote their thesis on Wang tiles. But yes, this is undecidable. And the question is, again, you have tiles. Assume you have all you want of each one of them, in this case, 4 tiles. And they have colors in each edge. And you want to be able to tile, say you want to tile the floor. And when you match tiles next to each other, they have to have the same color, left and right or top and bottom. So here's an example using the tiles we see here. Here we go. This is a solution. You can tile, in fact, you can tile an infinite floor. If you can see a dark square here, there's a 4x2 square of the tiles. And in that 4x2 square, all the colors on the top match the colors on the bottom, the colors on the right match the colors on the left. And so you can duplicate that group of 8 forever and tile an infinite floor. So it's tileable. Unfortunately, the problem is undecidable. You cannot always tell if you can do this. And as you get more and more tiles involved, with more colors, it becomes more difficult. Now that the previous example, there is a periodic repeating tile. There tends to, somebody found that there's non-repeating solutions, solutions that go forever. Here's one, here is this set of 13 tiles. Again, you can't rotate them or flip them or anything that you can use. And yes, you can tile the floor forever, and the pattern never repeats. This is kind of interesting. The pattern never, they can prove, there's a proof that the pattern never repeats. They assign numbers to each of the colors, and then they say, these are all multiples of 2, and these are all multiples of 3, and never the twain shall meet. And so, okay, that's non-decidable, but we're getting a little far afield. Let's go back to security and access matrix. So again, the purpose of that was, no, you cannot write a antivirus or security system that will analyze your program and tell you, is it secure or is it not? Now, there's lots of programs that do that, and most of the times they can tell you, yes, it's got its problem. Finding a problem is pretty simple. If they don't find one, you don't know if it's secure. It's not possible to do that. Okay, let's talk about access control. When we want to access control, we'll divide the world into subjects and objects. Subjects are things that want to access an object. And objects are things like files, devices, software entities that they want. Subjects are users, people, or programs running on behalf of people, and they want to access a file or something. So you want to access a file, or your program wants to access a file. And the question is, can you access that file in that way? Note that other processes can also be objects. Can this program access that program? Can this program access that activity on let's say, an Android phone? You have lots of activities going on that often represent devices. Can this program access that activity which looks at the camera? Yes or no? Okay. You can make a matrix of all the, this case, we have all the objects across the top and all the subjects along the y-axis. You notice that Alice and Bob are both subjects and objects. And I think this is our first introduction to Alice and Bob. When you read security and cybersecurity documentation books, you'll always see Alice and Bob. Somebody years ago started using Alice and Bob as the two users in any secure system. And so Alice is always sending a message to Bob. So why be different? Alice and Bob are here. Alice wants to send a message to Bob. Alice always send a message to Bob. And there's usually somebody else who's trying to look at them. And Charlie might be trying to look at the messages. So Alice is sending a message to Bob. You'll see Alice and Bob again and again in all you read. Okay, so here you might say Alice has the rights to the file probe.exe that she can read and execute. She can read, write, and own the xyz.txt file. Bob can only read that file, can't write it, can't do anything else in there. So these are the things that one subject can do to those objects. Pretty simple concept. Okay, and again, a subject might want to read the file, write it, or delete it. Those are things you might do to a file or an object. There may be other things. I guess there may be others. Those are the common ones, particularly for files. And if you want to take it up, if one subject wants to take an action on another subject, typically you want to send messages. You can send messages or receive messages from an object, or one program can execute the other program. Those are things that you might do. One of the permissions we saw on the chart was own. This is sort of a special permission. When you create a file or an object, typically you are the owner of that object. The owner has abilities that the regular user doesn't have. The owner can usually give other users or grant other users privileges to access that object. So you have to own it to do that. In the Microsoft world, you have to have full control in order to grant objects. We'll get to that. Okay. So typically, if you now, it is also possible in some systems to take ownership of an object. You can request ownership, and we'll talk about that later. Okay, but yeah, so by default, when you create it, you own it. Later on, somebody might take ownership of it. Okay. Last week, we mentioned some of the goals, and the most common ones you'll see are the CIA of confidentiality, integrity, and availability. You also had authentication. Never mind. We have three other A's. Well, won't even go what they are because I'm not going to say. Okay, let's define those CIA things a little bit more formally. Okay, coming from the textbook, if X is a bunch of subjects and I is some information, then I is confidential with respect to X if no member of X can obtain information about I. That's the textbook one. That's kind of an inverse, in my opinion. So I redefined it as let Z be a subject of a set of subjects. Z, of course, is some subset of S. And so if you got some information and object, then I is confidential with respect to Z or Z if only the members of Z can get information about I. You'll look at them and they're exactly the same. One is these people can't and these people can. So that's form. And it's confidential if no unauthorized subject can read any information or see information about that. Okay, pretty straightforward. That's for confidential. Integrity, pretty much the same. Z be set of subjects and I some information, then it's you have integrity if only Z, if only the subjects in Z can modify I. So only if only the subjects in the subset Z can modify the object, then it's got integrity in respect to Z. Okay. And you can look at the other way, textbook, if X is a subject, then I has a property of integrity with respect to X if all the members of X can trust the information in I. So bringing the idea of trust here. So you can trust the source of information. In other words, if you have information, you can trust that it comes from where it says, that it has not been modified by anybody outside of the subset X. Okay, pretty straightforward questions. That, again, we're applying sets to these things. And the last one is availability. X is a set of subjects. Then it's available with respect to if members of X can always access I. And so for availability, you can always access it when you want to. And it's unavailable if you can't get there, which generally means that somebody's broken the availability if they've stopped you from being able to access that resource when you want to. It should be noted that sometimes you might have to wait to access the resource. Now, just because you have to wait doesn't mean it's unavailable, as long as it is a finite, reasonable length of time. Some resources can only be used by one process at a time. And so if you want to use that resource, you may have to wait for the other process to use it. A printer. If your program wants to put something in the printer is only going to print one document at a time. You don't want to interleave the lines from my document and your document. So your program may have to wait till the printer is available, but it's a finite amount of time. Of course, usually most systems, they will queue these, but there is a waiting. Okay, in the Unix systems, we'll talk about Unix access control. Unix defines three separate organizations of people. There's owners or users. The actual word for these things depends on whether you're old and gray like me or you're using a newer book. It used to be user group world. Those of us with gray beards, remember user group world. It's been around the Unix since the dawn of Unix, which is about 50 years ago, but I remember. Okay, and so the owners group. The owner, of course, is the person who created the file. The person who has the owner right to that file. Who created it? Group, you can have groups in Unix. You might be a member of that group. So typically, if you're in a group, and then the group may have access. And world or everyone or others means this is what everybody can have. So you might say, well, everybody can read this file. And of course, there's read, write, and execute. Those are the properties that a user might have of this file. By the way, if it's not a file, if it's a directory, you have files and directory. If it's a directory or folder, you might have the access to look in the folder. So read, write, execute. If it's a folder, in that case, you might look into it. So in the Unix world, if you do the ls command, or in this case, ls -l, it will show all the files in your directory, and the -l is the long listing. And this is what you might see. And you will see, I would say, look at the first one. There's user, group, and world. Each one has 3 characters. Dash means it's not set. In this case, we're saying that for the file adc test3.cpp, that the owner has read and write, the group has read, and the world has read, execute. Down here for adc test4.out, let's see if I can make this. Oh, yeah, okay. Yeah, for the output file, the user can read, write, and execute it. Group can read and execute. The world can read and execute. Okay, and down here we have a directory, and yes, everybody can access that directory. All right, easy enough. Read, write, and execute are the abilities, and there are only 3 groups. You can change permissions. There is the change mod command in Unix that allows you to change the permissions. You obviously have to have ownership permission to change this. If you don't have ownership permission, then you can't change the permissions. We'll talk more about that in a minute. Okay, there's you can add, plus signs for add, minus for remove. There's U for owner. What? Yeah, I think it was user, group, and others, and A for all, all for everybody. And then there's RWX for read, write, execute. So if you wanted to give the user read, write permissions to my file, then change mod U plus the user, being the user, plus read, write, And then here you can say, everyone's going to be able to read this file, R plus R. And then over here, it's a little more complex. We've got two of them we have. Change model, we've got the user gets to read and write, comma, the group and everyone remove the ability to read, write, and execute. So they can't, everybody else can't do anything, but the user can read and write it. Okay, good enough? Now, before they put those fancy letters there, they just had three numbers. You can think of them as octal, decimal. Think of them in numbers. If you represent the numbers in binary, if the numbers go from 0 to 7, they represent 3 bits. That's read, write, and execute. Unix was developed by programmers long, long ago, and it didn't go to a lot of effort to make it easy for users. They meant for other systems programmers to use. So in his case, if you go change mod and put 3 octal numbers here in the file name, and if you convert 704 to binary, 7 is 111, of course 0 is all zeros, 4 is 100. So the user gets to read, write, and execute. The group gets to do nothing, and everyone gets to read. Okay. Note that in the Unix world, you can specify permissions for the world, you can specify permissions for a group or the owner of the file, the user. But you can't say Mary gets to access the file with read-write permissions, but Joe cannot. And you can only say those 3 groups, the group, the user, or the world. But typically, it's the world. So you're going to, because even though the groups, in my experience in using Unix, or Linux, by the way, when I say Unix, Linux, same thing. Linux is just an implementation of Unix. Very rarely are groups actually used. I've never used groups in Unix, but so that's it. Okay, so everybody understand that? Then everybody should be able to answer this question. So we are going to try this. If you are online, you should see the poll. Somebody on the online world, tell me if you can see the poll. Somebody's okay. We got a yes.
Yes, we can see it.
All right. Well, then start answering it. Now, if you're sitting here in class, you might not be polling those. I have an alternative. I've got these. Here, would you hand these out? All right. Yeah, give everybody one. Give them one. Okay. Yes, these things. These are called clickers. They have 4 letters around the edge. Oh, which doesn't work well because there's 5 possible answers. Here's the I have to work on that issue. So what you do is you look at the question, you go, oh, the answer is D. Then you hold up your card so I can see it with the D at the top. Now, cards are different. This D and that D, so you can't tell, unless you look really carefully at the other person's card, you can't tell what they're voting. But the app on my phone can. The app on my phone can read those clickers and, oops, if I get it. Okay, skip that idea. Smartphone, behave. All right, so everybody a chance to figure out the answer? Hold up your cards. Be careful you don't obscure the code. It needs to see that phone. So everybody got the concept? Everybody look. So if you think what the answer is, hold up the card so that number is at the letter. The letter is at the top, holding in the corner so you don't obscure it. And now I'm going to take a look at, I can see, so hold up so my phone can see it. Okay, up there. Oh, yep, gotcha. Everybody, click. And oh, no. All right. Let's see. All All right, the answer is read. The folks in class are paying more attention than the folks online because they had a lot more people answer read than online. Here, we'll, oh, snakes. My mouse is stuck. It won't get out of the image. Well, can I move it someplace else? Oh, there we go. Okay. That was fun. Share the results. That's the online. Well, you can't see the online people. Okay. The answer is read. Let's talk about why the answer is read. All right. The number is 754. We want to know everyone. So everyone is the last. It's user, group, world, or everyone. So 4 in binary is 100. And it goes read, write, execute. So it's read. So the answer is A. Everyone can read. Questions about that? Drawn. Oh, yes, sir. Yes, world or everyone.
I had a question as well about that last one.
Okay, let me answer the inline. Don't go away online. Yes, again, if you look in this particular problem right here, again, there's a 4 there. That's 100 binary, so it's read, write, execute. So it doesn't matter what the other digits are. The 7 and the 5 don't really matter for everyone. It's just the okay. If you think of everyone, you think, is the user part of everyone? Yeah, no, we don't usually think of the user as part of it. Yes, online, you had a question.
Yes, I was just wondering, can you go over that again? So are you saying the 4, because there's a 4 there, when you convert that to binary numbers, it automatically means this file is a reading file?
Yes, okay. Again, you have to know your binary numbers. That, I guess I didn't mention that as a prerequisite for the class, but we can work on that. There's only 7 of them to remember, or well, 8, I guess, 0 through 7. It's not hard. 4 is 100 in this example. 100 is in binary, and the bits are read, write, execute. So if it's a 1, so backing up to this thing, we have, this is the result of printing out the permissions for all the files in the directory. Do the, in Unix or Linux, it's the ls command. You'll see this, and you get read, write, execute. Here's a read, write, execute for the user, read and execute for the group, read and execute for the world. So you have to look, so you convert number to binary, particularly for that group. In this case, it's everyone. And then read, write, execute. This has the 1 bit for read. So did I answer the question? Did it make you more confused than ever?
No, that actually helped. Thank you.
Okay, well, we'll settle for more confused and go. Oh, yes, sir. Is what? Read, write. Oh, yes. The user has read, write, execute. That's a 111. If we look up here, yes. This, the user has got a 7. That's all 3 bits, read, write, execute. Oh, yes, that would be 1. So you can say you can execute this, but you can't read it. What that means is you can execute the program, but you can't copy it. So you might want somebody, you might have a program out there, you want to make publicly available, people can execute it, but you don't want them copying it. So you make it execute access, but not read access. Command prompt.
I had a
Oh,
quick
yes, this
question,
would be at the
Professor.
command prompt. This is Linux command line.
I had a quick question, Professor.
Yes.
So because can you go back 1 slide to the answer?
That
So
slide?
because on the bottom, because all the bits are flipped for 7, that's why they can all of it, you can read, write, and execute that file, right?
That's correct. Yes. All the
Okay.
bits there are 1. 1 means you can do this. 0 means you can't do that.
Okay, thank you.
Okay. Did you have a question? That would, yes, you're correct. The 5 is a 101, which means they can read and execute. That would be a common permission if it was an executable file. Note, of course, that it is pointless to make it executable if it's a non-executable file. If you have a text file, making it executable just doesn't make any sort of sense. But Unix doesn't care. It's Unix. Okay, moving along. There are no more questions? All right, so we have an access control matrix. We showed a picture before, and we had rows for each user and columns for each object. Well, that can get large because there's, really simple. It's the number of possible users in the system times the number of objects. That can be big. You might not want to store all that. There are ways to do it. Basically, it's done in two different ways. They are called capabilities, which specify what can this user do. And then there are access control lists, which says who can access this object. So if you want to think about it, capabilities are rows. What can Alice do? These are the things Alice can do. These are the things Bob can do. And then access control lists these are who can access and how people can access, or the processes can access probe.exe or the other files. Okay, simple enough. Now, users are often formed into some sort of group where you can say, like, everybody can access this, or owners can access that, can do this. So you might say, again, everybody has read and execute access to this file. And so for that file, you don't need to keep every individual user. You just have to say, everybody can read it. And then the owner has a read, write, and execute. So you only have to keep two elements, much, much smaller than very large file. Okay. Let's talk about some specific systems. For instance, Android. We'll talk about phones access. On a phone, if you have, I'll talk about iPhones in a minute. We'll start with Android, alphabetical order. So you can specify what an app can do, what access rights an app can do. In this case, I'm talking about location. So I can specify that the blood donor, if you're a Red Cross blood donor app, everybody should give blood, then what permissions does this app have? This app is allowed to know your location when the app is in use. It cannot access the camera, cannot access your storage. Those are particular capabilities that this app may have. And you may give the app these specific, you can take away these or give these access rights to this app. Now, in the phone world, at least, yes, in the phone world, typically you look at programs, apps like users. There's only one person holding on to the phone, but each app runs as a separate user. At least Android has Unix deep inside it. And deep inside in the Unix world, in the phone and Android, every program is a user. And so they do security by user, where it says user, the users can access, that means this programs can access. So in this case, the blood donor app can access your location, but cannot access the camera or storage, and hasn't asked for things. There's all sorts of permissions you might give an Android. Well, you can have body sensors to measure your blood pressure, your heart rate, and other things, camera, some physical items like camera, microphone, physical location, those are devices. Then there are software entities like contacts. Can it look at your contact list? Storage, there's all sorts of things. What they are isn't important, but there is a long list of them. iPhone also has a list of things you can access. In this case, we're looking at location. We want to look at the location for a particular app. We want to set that. We can say, yes, this app has the right to look at my location. It will look at it using a GPS. Actually, location can be determined by multiple ways. GPS, how is it accessing the network? That narrows it down to towers or Wi-Fi or something. They're looking where you are very carefully. Okay, so in this case, specifying how the camera can be accessed. All right. You can specify what resources an application can have, and you can also, from the object point of view, you can say who can access this. So can the camera can access your location, not only but the precise location. In the Apple world, you have precise location, and the precise means it's going to use the GPS system. Imprecise means it's going to guess approximately where you are from how you're accessing the network. I want to point out that you should be very careful about this. When you give an app permissions, do not grant permissions that you don't think this application needs. And if the application will not run without those permissions, don't run it. The one example I had, and I downloaded an astronomy app. Astronomy app wanted to access my contacts. Why in the world does an astronomy app need to access my contacts? I mean, I can see accessing the GPS, accessing the compass. Oh yeah, those are necessary for a good astronomy app, but not my contacts. So I immediately just unloaded that one and got rid of that. No, watch for these. You'll find apps that are asking for things, even nice, kind apps that you think might be trustworthy. Big Brother always wants to know more than you think you should let it, so don't always give it everything it wants if you don't think so. All right, let's ask another question here. So, let me see if I can make this work. Okay. Another question there. And people here in the live studio audience, think about the answer here. How wrong can you be? You've only got 3 questions. All right, everybody good? Hold up those so I can see them. More importantly, so my phone can see them. Oh, yeah. Gotcha. Okay, yeah. All right. You'll notice, by the way, I don't know how you, as an individual, answer. I don't care how you, as an individual, answer. What I do care about is most people specified B. So yes, and well, you can see online, yeah, it's about the same result here in class. And you'd be happy to know that B is the correct answer. Access control list specifies how an object okay, let's go away there. All right. If you have A is specified what a user, that's capabilities. Capabilities are what a user can do. Access control list is who can access an object. All right. Okay. Just to oops. Okay. Now, attenuation approval. You can give other people, particularly if you're the owner, you can give other users rights to access an object, but you can't give them rights that you don't have, which, if you think about it, makes a lot of sense. You could collude with Fred, and if you don't have access to the object, but you could give access to Fred, then Fred could give it back to you, and you have, but no, you can't do that. You cannot give access to somebody you do not possess. Likewise, you cannot give yourself access rights that you don't possess. You can remove access rights, but you cannot give yourself access rights that you don't originally have. Typically, owners have the ability to give rights. So you can give away rights or take them away. Now, again, in Unix, there's user, group, world. You can't be very specific. You can only give it to groups. You can't say individuals. On the Windows systems, you can. You can go, that user can have these rights. Or on Android or iPhone, you can also say this application can have those rights. And then sometimes things get complicated. We have to merge rights. Let's talk about that for a second. Users can belong to groups. And groups might have rights, and the users might have rights. Programs that the users are running might have rights. So again, my example here, you download a program. You want to run that program. Should that program have access to everything that you have? Well, it may need access to some things. You want to give it access to everything. Now it starts to get, and then you have the access of those users and the access of you. How do you merge those? We may have a program that accesses sensitive information, something that you don't want everybody in the world to see, but this is what this program does. This program looks at information and provides that information to this user. you have this program that sits in front of this data and it's there to protect it. So this program can access that data, but the user otherwise cannot. So that's a little bit more complex. Also, sometimes you want to delegate. Again, the example here is that you are the manager, you're going on vacation, you want to give your lieutenant in charge permission to do these things, and then you, of course, later you want to take them back. And you might not want to give this person everything, but you might want to give them the permission to do certain things. So if these things happen, don't worry, Mary's in charge, she'll take care of it, she's got the permission to do all these things. Okay. Now, in Microsoft world, talk about Microsoft. We talked a little about Unix and Linux. Let's talk about Microsoft. And Windows sometimes looks like Unix and Linux. And sometimes looks like Microsoft, and sometimes looks like Apple and nothing else. But Windows provides a means of accessing things. You can have users that run on different computers and have different access rights. For multiple computers, Microsoft has the Active Directory system. That means you have a domain, you have a network of computers, a user can sit down to any computer and log in on that computer and access files on a server or access objects on that particular computer, which are controlled by Microsoft Active Directory. And so when you log in, you have to log in to Active Directory so the system knows who you are. And then objects are divided into trees. We're not going to talk anymore about Active Directory, but it is an example of a access control system that spans multiple computers. It uses the Microsoft Windows system. Probably most of you don't use it. I think the labs use it around here. I know if you are using a lab, you got a course that uses it, go into lab, it's Microsoft Windows, you can log into any computer, your files are always there. Yes. Okay. Most PCs, most laptops do not have multiple users, but the same operating system runs in servers, and so you can have multiple users. Again, sometimes some of the programs on your computer may run under different accounts, different users. When I had my desktop here, when I have an office, once upon a time I had an office, I was a real full-time faculty member, and I had a web page, and my web server was my desktop computer. So I could just easily put things on my web server by just copying a file into the proper directory. And when I sat there and typed up my slides, it was the same computer that people accessed and went to my web page. But I wasn't sure I wanted everybody on the web to access all of my files. So I had multiple layers, defense in depth. And one of the things I did is the user that runs the web page. There was one user that ran the web page, even though it was on my computer, and then I ran it under another user account. And the web user could not access my files. You could only access the files of the web system, of the web directory. I could also access the web directory, so I could copy things in there and change it as I needed to. But so sometimes you might have multiple users on a website. And of course, in server systems and big systems, you might have lots of users. And the example I said, background services, antivirus is a good one. They run in the background. They may access. Typically, of course, you want your antivirus to be able to access everything. You might have the operating system. You need to access everything. You may not be an administrator, so you may not be able to access everything. There is the important principle of least privilege that applies in many ways in computer security, and we'll talk about it throughout the semester. But the basic rule is you never, ever give a user or a subject or a program more permissions, greater access than it needs to get the job done. Far too often, people say, oh, we'll just give you root privilege and then you can do this. And root privilege allows you to do everything. Well, no, give them permission to allow them to do what they need to do. Don't give them permissions to do everything, because then they might do everything. It may not be what you want. Also, if a user has limited access and they do something foolish, such that another villain attacks them and gets access to their account, well, they can only access what they can access. If they are an administrator or root privilege, they can access everything. But if they're not, they may have very limited access. They can go out and delete their files, but that's all they can do. They can't access the system. They can't destroy the whole mess. But if you're a full administrator, oh, well, it's almost unlimited the damage you can do. So typically you want to run as limited a user as you can get the job done. Don't run with all the privileges that you might need. It's generally wise that, particularly if is to have an administrator account. And when you need to do administrator things, just log off, log back onto the administrator, do the administrator type things, log off, log back onto you, and then you're safe. Then if you access something. Okay, again, malware attacks, somebody accessing you can do all sorts of things. Okay. Microsoft, you can assign access to things. You can specify what users can do. There is something interesting in Microsoft. You can say that this account can only execute this program. It's really useful if you have a kiosk. Some places, a computer screen, might have a touch screen, and as soon as you turn it on, it boots up and runs its one and only app, and it appears on the screen, and you do it. Yes, that's you can't get out of that. It only runs that one app. That's useful. You can imagine you don't want somebody to mess with the computer that's running this kiosk touchscreen. So you can say this application can only, or excuse me, this user, this account, only run this program. That's it. That's all it can do. And then you can specify when the program starts, it runs that account. Microsoft has made it easier for people. Those of us remember, Microsoft systems way well. At first, they were open. Microsoft had no security at all, none, zip. And you could trash the whole system. Anybody could trash the system. And then they decided to get more security. Then they developed the security system we'll talk about in a minute. And then they backed off and said, well, it's too difficult. The users don't understand it. So they came up with simple. They came up with the idea, we will share our files. Press here to share. And that kind of works, sort of. There are other ways. What that does is it's a simplified way of implementing something under the covers, which says, oh, I will go out and allow everyone to have the read access to this file. So if you click the share button, that's what it does. When you go off and if you in the file explorer of Microsoft Windows and you right click a file, look for the file properties, you'll see something like this. And you can see all the privileges. When you click on security, the security tab, and you can see who can access this in which way. In this case, users. Here we have system, which is the operating system. And typically the operating system can do everything. W, that's me. I'm the owner. Administrator, what can administrators do? And then users, what can everybody else on this PC who is not me do or not administrators? And there's not that many on my computer. But if there were some, they can, for this particular file, and it's exam1.doc, that's the exam, you can read and execute it and read it. That's permissions you're allowed to have. Now, oops, back up. There is this button called advanced. If you click that button, you get here, and it goes more advanced permissions. And you can specify what permissions each user has. Notice there's the concept of inherited. By default, an individual file directory inherits their access permissions from their parent directory. So if you have a file, and the file is in a given directory, then that file accesses its permissions from its directory. In this case, excuse me, the file is in the comp 755 directory and the NCAT, and it all inherits from NCAT. So the comp 755 directory inherits from NCAT, and then the file inherits from that one. So that means you don't have to specify all individuals, and it makes it easy. By default, you inherit the capabilities of directory. You can't change that. You can click on the change, and then you go to here, and you can specify what each user can. You can add users if you want to specify a particular user on your system in case your laptop has multiple users, which it often doesn't. But think big servers. This is not uncommon for big servers. that you might have multiple users and give them other users. I think I just mentioned inheriting. Yes. By default, you can. Right down here, it says include inheritable permissions from this object. It's the default. And if you unclick that, then it says, okay, it usually copies the rights to your file, to your object, but they're no longer inheritable rights. You can change them individually. If you're inheriting the rights, and you can't change the rights unless you change the inheritance. You're not inheriting anymore. Okay. Groups in the Windows world, you can create groups. You can in Unix. I don't know if anybody ever does, but in Windows, you can create groups, and you can say, this is the engineering group. This is like, there's a whole bunch of default groups. I don't know if you can, that's pretty small font, but there are administrators, there are backup operators. So if you have software, there's a backup of your system, it will want to run under the backup account, and it will have backup rights. It's part of the backup group. You can have multiple users of the backup group. Cryptographic operators on all power users, remote users, all sorts of users, and administrators are up there. So administrators usually have lots of permissions. And so when you give permissions, you can give it permissions for a group, and the groups will have specific permissions. And you can say, this user is a member of this group, and therefore it has these permissions. Windows also has the concept of domains. You can be a member of a domain that's like a directory. You belong to this group of computers, and this group of computers can have groups. This domain of computers can have groups. You can have local groups that belong to your computer, and you have groups that belong to the network domain. And so if you're in a lab, you might have domain. Everybody in the domain has, this computer might have special permissions. Okay, you can add users to the groups. You can set the permissions. You can say, what can they do? And here's a whole list of things. Full control means they can do everything. But if you click that button, all the other buttons get clicked. Execute the traverse folder. Traverse folder means you can go to that folder. You can change the directory to that folder. Read, write, stand, all sorts of things. Delete it, all sorts of permissions. Directories, you can do other things. Directories, if you change the permissions for directories, you can specify, am I changing the permission for this directory or for this directory and everything in it? Frequently, when you want to change, you might change the permission. I do this a lot. When I go to a new semester, I copy last semester's files into a separate directory, and then I go out and I change permissions so I have only read access to that directory. So I can always go back to last semester and look at what I did last semester, but I won't change it. I want to change it, I have to copy it to a new directory and change it. So I don't mess up my copy of the last one, because it's very common for me to go out, open up a document, oh yeah, that's what I did, and then start editing a bit, and then press the save button. You go, no, you can't do that. Save it someplace else. So it saves me from messing up my stuff. You can do that. So if you have files that you don't want to mess up, change them to read-only access. Now, users may belong to multiple groups. And if they do, groups have different permissions. What is the end permission that they have? Excuse me. Okay. I tested myself. I don't have COVID. I have a cold. You can't get colds these days without everybody going, ah! So, no, I've tested. I flunked the test. I didn't study harder. Okay, there are multiple permissions. Basically, these are the order. There's full control, means you can do everything. Write means you can write file. Which, by the way, if you have write permission, you can also read and execute. That's, call it write, but it means read, write, and execute. Read and execute means obviously you can read the file or you can execute it, and read means you can only read it. And then there's deny. Deny means you cannot touch this file. You cannot read it, you can't write it, you can't delete it, you can't do anything to it. That is the highest priority. That's the highest ranking. Because when you merge these things, it's going to take the highest. So if you don't specify what a user can do, then they don't have access. So if nobody has specified this person can access that file, then they cannot. That's a little bit different than saying they're denied access. If you are denied access, then you can't, because when you merge accesses, the resulting access is the highest one you have. So we're backing up here. So if you have a group that has write access and another group that has read and execute, then you end up with write access. So if you belong to the engineering group that has write access, if you belong to the human resources group that has read and write access, then that user has write access because that's the highest. But if you belong to the engineering group that has write access and marketing is denied, and you belong to both groups, then you do not have access to that object at all. Likewise, if somebody didn't specify whether you have access, but you're a member of a group that's denied, you just don't have access. Deny is the highest one. No matter what another group has, if you're denied, you don't have it. Okay, so that brings up to yet another question here. Let's try this one on, whoops. Keyword is launch. Okay, hopefully the online word. And okay, we'll do it here in class. You know, you can look at it. Okay, everybody understand the question? Everybody understands the question? Okay, let's figure out if we understand the answer. All right. And we will try again. So once you are comfortable with the answer, let's hold up the card with the proper letter to the top. Hold it up without, okay, keep your hands off. All right, let's try it. Oh, you were at the, hiding in the back. Put it up there. Oh, yep, I got it. Oh, got it. Okay, we got it. Oh, we have a tie. Oh, okay, they're still out there online guessing. I think we got 75% of the people who participated. If you're online, sometimes you might have fallen asleep. I just woke up everybody in class. Okay. Full control is a very popular answer. Sadly, it's the wrong answer. The answer is C, right, because Fred is a member of the advertising group, which is right. Ooh, lost my little shiny. Fred is right. And he's a member of HR, which has read and execute. So I have them listed here in the proper order. Right is more higher. Nope, not. So we can read, write, execute. You might think full control sounds like read, write, and execute. But full control means owner in the Windows world. So not only can you read, write, but you can you can give other people access or change access. Whereas if you have read, write, and execute, you can read, write, and execute, but you cannot change that. You can only read, write, or execute the file. You cannot change its control. That is attenuation of permissions. You can't give somebody permissions. Or you can't. Yes, we have a question.
Yes, I had a question. Sorry. So does that mean basically, since Fred is like he had the main access to write the HR group, that has nothing to do with him giving the full access? I'm a little bit confused on the question.
Okay, first of all, you have to understand that full access is different from read, write, and execute. Write, by the way, when you have write, it means you can also read and execute the file, but permission is called write. It's you can read it, you can write it, you can execute it. So because Fred has the write permission, he belongs to the advertising group, which has write. He belongs to the HR group, but they have lower permission. So Fred always gets the highest permission available from all the groups he belongs to. And since the highest permission is write, it's higher than read and execute. So Fred gets to write. Does that answer your question? Okay.
Yes, it does.
All right, moving on. If that wasn't confusing, try this one. Okay. Okay. Hang on. All right, we're moving on. All right. There we go. We're looking for what Joe can do. Oh. This is gonna be hard for the people in line in class because they're give it away. The answer is the ones you can't do. So yes. All right, we're gonna call an end to this because I've messed up here on, but we'll just, okay, everybody look at this. Almost all of you got it right. Okay, and Paul, okay. Yeah, most of you got the right answer. The answer is read. Joe has read permission and the HR group doesn't specify, so he gets this permission he has, even though if he wasn't a member of the PR group, he wouldn't have access to click.text, but because he is a member of the PR group, which has read permissions, he can read. That's all he can do. All right, one more. We're not done yet. We're not done yet. Okay. There we go. If you're not, this is my last question. Everybody. Oh, shoot. I can see that wire is going to break everything. Okay. All right, hold them up so we can see them. Yeah, ragged edge with them. Go ahead, so you everybody. They'll hold it up again. You got your hand over the corner. There you go. Yeah. It's that's see the whole thing. Actually, I think it's cool. It works. Oh, that's it. Here's this one. All right. Oh, yes. We have almost a tie. How are we doing? Okay, 83%. Okay, about to see. Yes, we have full control is very common. Here in class, people think right is very common. Unfortunately, the answer is none. A. Our Susan belongs to the accounting group, which has deny. Deny has the highest priority. Backing up. Deny is if you're in a group that is denied, no other group will allow you to access that object. Sorry, I'm tripping over the wires, which are fraying. So if you're a member of the deny group, that's it. You cannot get any other access. So I should have a wrap-up slide, which I don't, but basically you have access control matrix. Access control matrices can be implemented as capabilities for users or access control lists for individuals. You can group people or subjects into groups, and then they give groups permissions. You can merge the groups. When you merge the groups, the individual user has the highest priority of any group that they're in. Remembering in the priorities that deny is the highest priority. You might not think, but it's the highest. Okay, so you can't give people permissions that you don't have. Owners have the right to give permissions. And in the Windows world, that's full control, which is more than being able to just read, write, and execute a file. You can read, write, execute, and you can control access to it. By the way, if you have a write, you can also delete the file. All right. Any questions? Then I just have some announcements. Your assignment will coming out. Yes, quick, real assignment. If you haven't done the introductory survey, and 83% of you have, at least this afternoon, it is due by noon tomorrow. If you're one of the 17% who haven't, then get with it. Go out there and do that. It's 100 points. It's a quiz. It's the easiest quiz, the easiest assignment you'll have this semester. Don't blow it. Start off with 100 points. Everybody has an A average so far. If you don't, you have an F average and you're screwed. Okay. But Coming up is another assignment. You will have to download some files from comp 620.free.nf. Note, by the way, even if you're a comp 422 student, the comp 620 is the name of the server. This is the shorter name. I didn't want to comp 620. And also I started it last year, and last year they surprised me with comp 422, which I didn't know until like the second day I was teaching. Oh, I'm teaching that class too? Well, how about that? Anyway, so try this. It's comp 620.free.nf/encrypted/ then your email address. So what is it? I'm Williams. If you're, don't put the at Aggies and don't leave that out. Just put your what is known as your username in the university .zip. It is a zip file. You're going to download that. You also need to download this file, common passwords.list. We'll be using those two files. Notice, of course, everybody has their own individual zip file. You can download it. It's encrypted. You can look at it if you want, if you can. I hope that you can't because I encrypted it. If you can look at it, do let me know how you did that. I'd be interested to hear. I really would like to know because the next assignment is to figure out how we can look at that. And in fact, we should be able to do that. Again, textbooks, I apologize for not making that link available earlier. Yeah, I missed the memo. And
We're done.
what? Yes, hello? Online question? Nope, they went away. Textbooks. There's a textbooks link. Make sure you look at the textbook. We should be reading chapters 1 and 2. 2.3, I didn't get much nourishment out of 2.3, so you can just breeze over that one. Security research. People ask me about who's doing security research. Here it is. All this is on the notes, by the way. If the slides are on Blackboard, as they always should be. Oh, by the way, if you get the slides on Blackboard, you notice the announcements are only at the end. Usually show in the beginning of class, the end of class. So, and the questions aren't on the slides on Blackboard either. Okay, you can see who's out there. That's these people. And again, remember, for all your classes, tomorrow is the last day to add a class. You want to add a class this semester, change the semester, change a class, you decide you're tired of this old Dr. Williams, take something else, anything else. You can only do that, you got to do that by tomorrow. If you're in the class by tomorrow, you're stuck. Now you can drop classes till sometime in October, but you can't add a new class. Also, I think they'll charge you. I don't know. I don't know how they do money. I don't do money, but yeah. Okay, that's it. Any questions about class today? Yeah, oh, we have a question.
Yeah, this is posted, we had down, type it in our regular search bar.
Yes, hopefully, yes. Yeah, there it is. Yes, you should be able to just type it in your browser and it should come up with it. Notice that you're gonna have to download that zip and download LS. Let me know if you have problems, if it doesn't like LST. When we get to the end, I could make it TXT and then you change the extension. If it does, some systems get upset with these files. We're gonna get around that. We're gonna do it. Okay. Unless that's it for today. We are.
Excuse me, sorry.
Yes.
I have a quick question. What do you suggest I do if I don't have a computer at the moment? I'm using the school computer when it comes to downloading that zip file.
Okay. Who are you, by the way? Oh, Ryan. Ryan's iPhone.
Yes. Yeah.
Okay.
My name is Ryan Douglas.
Ryan Douglas. Email me and we will figure it out.
Okay, thank you.
All right.
Yeah, babe.
Yep. Corey, do you have something to say?
Hold on one second, maybe. The LST file is not encrypted.
That's correct.
Okay, making sure. Thank you.
Yep, it's just a text file. Save it. You'll need it. Just
Awesome.
a bunch of passwords. The LST file, in fact, is 7,000 common passwords.
I got a question.
Yes, sir.
Yeah, where can we access that link to the website on Blackboard? Or is like, you gotta type it in manually?
Yes, it'll be out there. Just give it a try. Mostly I want a bunch of students to try it in case there's any issues. I could access it perfectly. My TA, one of my TAs said he had some issues that he could get around accessing it. I want to make sure that everybody can access it because we're going to need to access that. That's my server for this class. And if there are any problems, I want to know before I put the assignment out there. Okay. Then that's it for today.
I
Hey,
do have one more question before we log off. I just
Yes.
wanted to double check.
Ms. W.
Yes. I did look over your syllabus and it said that participation is usually like through the work and if you submit, we didn't have any like attendance thing today, right?
No, I don't do attendance. It's
Okay.
very hard with people in class, people sitting there watching me online, and then there's a bunch of students who can only watch the recording. And
Yeah.
so I can't take their attendance, but the university requires me to say, did they ever show up? And so I need you to do that introductory survey. Because if
Okay,
you don't
yes,
do
I did
any
that.
assignments, then I'm just gonna say you don't exist.
Right. Okay, all right. Thank you.
Okay,
Have a good one.
any other questions?
Yeah, could you leave the slide up for the link to the to your site for a second so I could
Oh,
type it in?
sure, maybe I can. Let's see if, all right. Yes, hang on for a second. Okay, the right button, I have to. And share. Share. Okay. Hopefully you can see that. And again, this will be in a assignment that will appear on Blackboard. You'll be able to click on it. Well, except for your email address. But I want to make sure everybody can do this. If there's going to be problems, let's resolve them now before we get into the assignment. Save those
Gotcha.
files. You're going to need them for the assignment.
All right, got it. Thank you.
And obviously, the assignment is to get into the encrypted file without knowing the encryption key. And we'll talk about how to do that.
Got you.
You're going to be a nasty hacker when the time you're done with this class.
Nice.
Okay. I don't want to do that. Stop sharing. Okay. Any other questions? Then see you on Wednesday.
Have a good day.